Alright, see ya. Oh, shoot. Alright, unit 6. So, I can convert from degrees to radians, radians to degrees. Determine location of an angle drawn as rotation in standard form. Use a calculator to find trig functions of an angle given in either degrees or radians. Draw an angle in standard form and determine the associated reference angle. Use a unit circle to evaluate trig functions. We're basically going to do these 4 today. They're really not that hard. Converting is super easy. Determine location of an angle. That means determining which quadrant it falls in. Super easy. Using a calculator. You should all know how to use a calculator by now.
I don't.
And then draw an angle in standard form and tell me the reference angle. That's probably the hardest thing we're going to do today. Alright, so first things first, what is a unit circle? A unit circle is a circle with a radius of 1. Right? You start at 0, 0, 1 over, 1 up, 1 over, 1 down. It has a radius of 1. It will also be broken down into these degree measures. We'll talk about that in a second. So it has a radius of 1. What is the radius of a unit circle?
1.
Thank you. Hey JJ, what's the radius of a unit circle? Thank you. Alright, glad we're paying attention. Good start. Alright, so when we talked about last week, we said we had to be in degree mode, right? Well, there's also these things called radians. Radians is when a central angle intercepts an arc that is the same length as the radius of the circle. The measure of that angle is determined to be 1 radian. So what that means, when we have an arc that is intercepted here, so this arc length is the same as the radius. So if an arc length is the same as the radius, it is determined to have an angle of 1 radian. Now, do you think you get to remember that?
I really hope not.
No. I don't. The idea that you know what a radian is important, but I'm not going to ask you in the test, what is a radian? You have to tell me, well, so the arc length is the same as the radius. You don't need to tell me that, right? You just need to know that there are such things as radians. Now, if we're talking about arc length, and I'm trying to measure this whole thing, all the way around, in radians. Right? I'm trying to measure the whole thing in radians. What is all the way around the circle called? The circumference. How do you find the circumference of a circle? Does anyone remember the formula for the circumference of a circle?
Pi.
Pi times diameter, or 2 times pi r. Right? So if I'm trying to find all the way around here, the circumference in radians, and I know the radius is 1, and I plug that in, what is 2 times pi times 1 in terms of pi? 2 pi. So what we say is there are 2 pi radians in 1 complete revolution. So if we talk about degrees, we say it's 360 degrees all the way around the circle, right? We all agree on that. Can I get some sort of feedback? Yeah? 360 degrees around the circle. If you're talking about in radians, it is 2 pi all the way around our circle. And when you get your unit circle tomorrow, you're going to have all those cool degrees around it. Or excuse me, Thursday you'll get it. You have all the cool degrees. You'll have all the radians broken down. It'll be 360 all the way around. It'll be 2 pi all the way around. So if it's 2 pi all the way around, how far is it to get halfway around the circle in radians? 1 pi. Right? 1 pi is the same as 180. 2 pi radians is the same as 360. Alright? Now, where do you think these numbers come from? 30, 45, 60, 90. Where do you think they come from? I have a guess. Like, where do you see 30 and 60 together in math?
90. Triangle.
What kind of triangle?
Right triangle.
A special right triangle, right? 30, 60, 90. 45, 45, 90. There's a reason we go in these increments. We go 30 degrees. We go 45, 60. Because all of our values for those come from special right triangles. Now, once again, you don't need to know how to create those values from the special right triangles. They'll all be given to you around the circle. You'll see that on Thursday. But that's where they all come from. That's where all those values will come from. It's from special right triangles. Right? Breaks down into 90. Breaks down into 45s, 30s, 60s. They come from special right triangles. Now, when you're going around a circle, and we'll see this when we deal with reference angles and terminal sides in a second, we always, 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 always start here for 0. 0 is always laying flat on that x-axis. Always. Always where 0 is. Never anywhere else. Okay? If I ask you to go positive value, so positive degree measure, or a positive radian measure, that means you're going from 0 and you're going up along our circle. If it's a negative degree measure, it's going down from 0. So we're going backwards. Right? Positive goes up, negative goes down. Okay? Yeah? Yes? No?
Yeah.
Any questions so far about the unit circle? Okay? What's next? Okay, well let's look at this. If I look down here, what are you more comfortable working with? Degrees or radians?
Degrees.
Degrees, right? Have you ever worked with radians before? No. So, first thing we're going to do is we're going to figure out how to convert back and forth between the two. That way, later on in this unit, when we're doing problems, and it says a cosine of 5 pi over 6, and you're like, I don't know what 5 pi over 6 is, you can convert it to degrees and use the degree measure. It's super easy. If that's what you're comfortable with, do it that way. You don't have to use the radians. Convert them to degrees. That's why we show it to you. Alright? Alright. So, to convert from radians to degrees, we multiply by 180 over pi. So if I have 3 pi over 4, I'm going to multiply by 180 over pi. Why do you think I do that? Why do you think I do that? Why do I multiply by 180 over pi? What happens? If I have a pi in my numerator and a pi in my denominator, what happens to them? They cancel. Right? That's the goal, is to get rid of the pi's. Anytime it's in terms of pi, that means it's in radians. So I get rid of my pi's, and on to degrees. So 3 times 180 gives me 540 over 4 times 1 is 4. So you just do 540 divided by 4. Should give us 135 degrees. That's all it is to change from radians to degrees. That's it. Right? We're trying to get rid of pi, because then we go from radians to degrees. So 3 pi over 8 times by 180 over pi. Cancel. Cancel. I get 540 over 8. What's 540 over 8? 67.5 degrees. So 3 pi over 8 is the same as 67.5 degrees. Last one, negative 13 pi over 6 times 180 over pi. I's cancel. Negative 390? Negative 390 degrees. Now, you're going to tell me, oh, Mr. E, they always said we can't have a negative angle measure. Right? You're right. When you're dealing with like angles in a square, or angles in a triangle, or angles in a shape, you can't have negative angle measures. But that negative sign is telling us what? It tells the direction, right? That's why it's okay to have that. It's telling us the direction to go from 0 is down instead of up. So negative is okay. Having greater than 360 is okay. That just means you're going around more than once. Okay? Those are fine. Alright, so from radians to degrees, it was multiplied by 180 over pi. What do you think going from degrees to radians will be?
Pi over 180.
Pi over 180. Right? So we're trying to add pi into it to make it a radian, right? Radians are in terms of pi. So I'm going to put 18 over 1, I'm going to multiply by pi over 180. All we're going to do, multiply across 18 pi over 180, and then reduce your fraction. Absolutely do not give me a decimal. Do not give me a decimal. Do not multiply 18 by pi. Do not do 18 divided by 180 and give me a decimal pi. Radians are in terms of pi, and they are fractions. They are reduced fractions. So in this case, 18 pi over 180 can reduce to pi over 10. And that's the radian measure. Pi over 10 radians is the same as 18 degrees. Okay? Negative 40 degrees. Put it over 1 times pi over 180. So I get negative 40 pi over 180. Well, negative 40 pi over 180 reduces to what? Negative 2 pi over 9 radians. Good. Any questions about that? Okay, let's try the third one. 100 degrees times pi over 180. So 100 pi over 180 reduces down to 5 pi over 9. So 5 pi over 9 radians is the same as 100 degrees.
Baseball.
Okay.
Is your game still on? You literally play the same field.
Your game got canceled.
It's the field right next to it. It's like 10 feet away.
Your game got canceled.
So,
Well, maybe your
she
field's
didn't-
underwater. I don't know, man.
Not even
Just
get
said
it.
I don't know what to tell you.
Same field. So no, we're gonna take what's not.
Here. Hop squat.
Do you want it to be
Alright.
sidetrack?
Any questions about going radians to degrees, degrees to radians? Pretty easy, right? Alright. Get your calculators out. Finding trig values in your calculator. So last unit we said we were always in degree mode, right? This unit, depending on what we're given for an angle, will be between degrees or radians. Anything with a pi in it, pi over 6, 4 pi over 3, you're going to have to be in radian mode unless you do what?
Change it to degrees.
Change it to degrees. So, how you would do that? The first one, sine of 20. I'd go into mode. I'd make sure, well, I'm doing 20 degrees, so I'm going to be in degree mode. So I go over degree, hit enter, and I would do sine of 20. I get 0.34. Next one I look at it, it says cosine of pi over 6. Well, pi over 6 is radians. So I'm going to go back to mode. I'm going to go down to radian. Hit enter. Quit. Cosine. Pi divided by 6. Enter. 0.87. So depending on what type of angle measure you're given, whether it's degrees or whether it's radians, is going to depend on which mode you're in. Alright? So like tangent of 5 degrees would be degree mode. Cosecant of 40 degrees, degree mode. Secant of 4 pi over 3 radians, radian mode. Cotangent 900 degrees would be degree mode. But hold on a second. Last unit we figured out we don't have a cosecant button. We would put it 1 over sine, right? We would take the reciprocal of it. 1 over sine of 40 degrees. Secant, the reciprocal of cosine, right? 1 over cosine 4 pi over 3. Cotangent, reciprocal of tangent, 1 over tangent 900 degrees. Go ahead and do those 4. Do those 4. Put them in your calculator. Make sure you're in the right mode. What's up? Thank you. Oh my goodness. see them mark the left? All right, what did we get for tangent of 5 degrees? Anybody?
0.087.
0.087. Do we all agree? 0.087 sounds like 0.09. Moving around to the 100th?
Yeah.
Okay. It didn't tell you what to round to, so. Okay. What about 1 over sine of 40 degrees?
1.56.
1.56? Okay. Someone besides Simon or JJ or Xander. What do we get for 1 over cosine of 4 pi over 3? I know we're all punching in our calculators. I know we couldn't just be sitting there waiting for everybody else to say it. -2. Thanks, man. -2. All right. What about 1 over tangent of 900 degrees?
Air.
Zero.
0? You got 0 to come up on the thing?
Divide by 0. Air divided by 0.
It says error. Good. It should say error. Because punch in tangent of 900 in your calculator once. Not 1 over. Just do tangent of 900. You get 0. Can I divide by 0? No. What happens when we divide by 0? When we divide by 0? We get error. But what is it? What do we put here? What? Undefined. Right? Sorry, I couldn't. No one was saying it loud enough. We were all like scared to say it. Undefined. Undefined, right? We cannot divide by 0. Now, sometimes we get an error because it's 0. That's undefined. Sometimes we get an error because we're in the wrong mode, though. So we gotta be careful. Right? Make sure you're in the correct mode. All right. Any questions on putting it in your calculator? No? Sweet. Then, determining quadrants. So we should all remember that there are 4 quadrants from earlier in our math life, right? I don't need to put it. Quadrant 1 is the top right quadrant. We go counterclockwise. 1, 2, 3, 4. Right? 1, 2, 3, 4. Now, a lot of times we're going to give you an angle measure. We'll be like, where does the terminal side land? Or what is the reference angle? We'll talk about reference angle in a second. We need to know where our terminal side ends up. Well, first of all, we should probably know what a terminal side is. What does the word terminal mean? If you have a terminal illness.
Death.
Not death, but like you're going to die. But the end, right? The end. So terminal is the end. So if it was the terminal side, it's going to be where our angle ends. So we said it always starts over here. It always starts at 0. The terminal side is where we end up. All right? So we're going to ask you, where does the terminal side end up? Or what quadrant does the terminal side land in? Well, in this case it would have been quadrant 2. That's where our terminal side is. But our terminal side is wherever our angle stops. All right? Now there's a positive way to get there. We said to go up. There's a negative way to get there by going down. Does that make sense? Yes, no. Okay.
Yeah, just got it.
Okay. So, in what quadrant or on which axis does the terminal side of the angle lie for 4 pi over 3? How many of us know how far 4 pi over 3 is on that circle? So that's 0. 0 of us know. So what should we do?
Convert it to degrees.
Convert it to degrees. Right? If you don't know, if you can't figure it out, convert it to degrees. Multiply by 180 over pi. We get 720 over 3, which equals, what? 240 degrees. So what I would do, because I need to visualize things, I would draw a picture. Draw the 2 axes. Right? I'm starting here. Starting right here. That's 0. I'm going 240 degrees. How far did I just go?
90.
90. How far did I go now?
180.
240's got to be somewhere in here. Right? It doesn't have to be perfect, but I know 240 is between 180 and 270. So what quadrant did my terminal side and my ending side end up in? 3. So quadrant 3, or Q3, would be my answer. Isn't too bad, right? Same thing for the second one. Negative 5 pi over 4. Multiply by 180 over pi. I think it comes out to what? Negative 225 degrees. Okay? Well, draw a picture. Starting right here. Starting at 0. I'm going negative 225. So I'm going down. 90, 180, right about there. 225. My terminal side or my ending side, where does it end up? Quadrant 2. Q2. Okay? Does that make sense? Alright. Times 180 over pi. Comes out to 810 degrees. Now, anytime we ask you to draw the angle or draw a reference angle, we'll talk about reference angle in a second, or draw the terminal side and where does it lie, you must draw the pictures like this. If it says to do it, you have to. Right? You need to draw the angle, which way you want. You need to draw the terminal side. Okay? Now, in this problem, it doesn't say to, so it's perfectly fine not to. But if it tells you you need to, you must. When it looks like this, we have 810 degrees. I'm still starting at 0. But I want to go around more than once. So what I'm going to do is I'm going to go around once, that's 360. Another time, that's 720. I need another 90 degrees. So my terminal side ends up right there. Yes, you need to draw going around all those times. Because I want to see 810 degrees. I don't want to see 90 degrees. So if it asks you to draw it, you will have to draw it around twice and then end up where it ends. Okay? What quadrant did I just end in? Why not, JJ? It's in between 1 and 2. It's not in a quadrant, but it is on the what? Y-axis. So the answer for this one would be y-axis. If it ends up on an axis, that's what you put. You don't put 1 and 2, or you don't put neither. You don't put none. It's the y-axis. Okay? Any questions on that? Sweet, because that leads into reference angles. So, reference angles. Reference angle is the acute angle found by going from the terminal side to the nearest x-axis. One more time. From the terminal side to the nearest x-axis. Always, always, always the nearest x-axis. So, your reference angle will always be positive, and it will always be less than 90 degrees. Right? If it's going to an x-axis, it should be less than 90 degrees. It will always be positive. Whether you go forward or backward, it's still going to be positive. Okay? Now, if we're looking at these, if our terminal side is in quadrant 1, my reference angle will be going from there, going back to where it came from. So it would just be that angle that I was given. The positive part of the angle, I should say. If my terminal side lands in quadrant 2, my reference angle is from that terminal side to this x-axis. That's the nearest one. So I would take, to find that reference angle, I would take 180 minus my angle. A little shortcut. If my terminal side lands in quadrant 3, my reference angle is from that terminal side back to the x-axis. So to find that reference angle, I would go my angle minus 180. Right? It's however far it is from that terminal side to the nearest x-axis. And lastly, if I end up in quadrant 4, from my terminal side to complete the circle to that nearest x-axis, you could do 360 minus the positive angle. Okay? Luke, when I'm looking for a reference angle, it's from the terminal side to what axis?
X-axis.
The x-axis, thank you. The nearest x-axis, right? Not the next one forward, not the next one back. The nearest x-axis. Any questions? Alright, let's try some. So we're looking for the reference angle for the following. The first one I went 135 degrees. So my reference angle will be from that terminal side to the nearest x-axis. It's in quadrant 2, so what I would do to find it is I would take 180 and I would subtract off this part I already have. So I want this part here. I'd get a reference angle of 45 degrees. Okay? The second one is in quadrant 3, right? It's 210 degrees. So from my terminal side back to the x-axis. So I want to take my angle and I want to subtract off this 180 part. So 210 minus 180 gives me 30 degrees for a reference angle. And the last one with the picture, where we give you the picture, 300 degrees between the quadrant 4. I need to figure out how far is it to complete that circle to get to that nearest x-axis. So I'd go 360 minus 300 equals 60 degrees. Does that make sense? Yes? No? Okay. Sometimes we give you the picture like those three. Other times, all we do is give you the angle measure. Now, if you can do it in your head, great, go ahead. If you need to visualize it, what do you think you should do?
Draw it out.
Draw it out. Starting at 0, going 225 degrees puts me in quadrant 3. So I know my reference angle will be from there back to 180. So 225 minus 180 would give me 45 degrees for a reference angle. The next two, like 100 degrees. You're right about here in quadrant 2. My nearest x-axis would be going from the terminal side and continuing to 180. So 180 minus 100 will give me 80 degrees. And then the last one. For an angle that measures 350, what's the reference angle? Well, 350 would be almost all the way around, which means my reference angle will be completing that circle to 360. 360 minus 350 would be 10 degrees for a reference angle. Alright, so we did converting degrees of radians, radians to degrees. We did punching in our calculator. We did figuring out where terminal sides lie. And we did reference angles. Those 4 things we did all in one day. Any questions? Sweet.